Hope you are all doing well, and in this tutorial I'm gonna teach you like 5 source code organization guidelines and best practices in Kotlin. So in these guidelines, this guidelines and best practices for organizing your source code in Kotlin projects. It will help you ensure readability, maintainability, and consistency in your entire project and your code, okay, itself. So let me go through what we're gonna talk about. These 5 different source code organization guidelines is like we're gonna talk about directory structures, source file names, source file organization, class layout, and interface implementation layout. Okay, so let's jump about the directory structure. Okay, so in pure Kotlin projects containing only Kotlin code, the recommended directory structure mirrors the package structure, omitting the common root package. Whereas in the mixed Java and Kotlin projects, so in projects using like both Kotlin and Java, Kotlin source files should reside in the same source root as Java files, following the same directory structures. So each file should be stored in the directory corresponding to its package statement. So if your code resides here, as if you can see, this is the example, right? So in this example, uh, so file belonging to this is my folder. So actually I'm using a compose multi-platform project structure here. So file belonging to the Kotlin are already directly installed, placed directly into the source root. Okay, so and whereas for example you see that file belonging to all this package name is being directly placed here. But whereas if you have a particular subdirectory, like for example if you go and check it out in the Kotlin tutorials package, like you have another sub package called network, right? So network, this is the subdirectory which consists of another, it's file. Okay, so it's called new network utility files. Okay, so you need to just focus on this concept about directory and subdirectory packages and its sub packages. Okay, so the source file name, in source file name, there is if you go and check it out, like inside my file, so there is my Kotlin tutorial class. Okay, so this single class, or it's if a file contains a single class or interface and potentially related top level declaration, its name should match the class name with the with the Kotlin, right? So this is my class name. You see my Kotlin tutorial class, my Kotlin tutorial, it's like they are matching because this is a single top level declaration. Okay, so it should match. Okay, you should not mismatch this. For example, you cannot write here a different name, okay, because it's just a single file. Okay, so if there are multiple classes for the source file name, file names, if there are multiple classes or top level declaration, if the file contains multiple classes, like for example I can see here multiple classes, um or only top level declarations using a descriptive name reflecting the file content, use Pascal case or Opel camel case for the file name. For example, if you can see here, this is a Pascal um, case or Opel camel case for the file names. Okay, so as you can see here, it's using this is the file name, and it has a multiple classes or functions, right? So it has multiple declarations, so that's why it can have a different name here, as you can see here, for the network utilities. And we use this Pascal case or Opel camel case for the file name. So for the multi-platform projects, in multi-platform projects, files with the top level declaration in the platform specific sources should have a suffix corresponding to the source set name. Like for example, for Android you have a Android, and for Kotlin you have a Kotlin, right? This is compose multi-platform, but in Kotlin multi-platform you will have a suffix, like for example, let me give you a simple example here. You will have a JVM main with the Kotlin, and you have a platform like JVM versus .Kotlin. So if it is a Android main, then it will have a plat. Okay, so this is just the example, right? Platform uh, Android.Kotlin. Okay, if this is for the multi-platform projects. For iOS main, you have to should define in this package platform dot iOS dot Kotlin. Okay, so this is how it is happening here in iOS, Android, and JVM. So files in the command source should have a should do not have a suffix. Okay, so in the if it is a command main, you do not have a suffix, like as you can see here, they don't have any suffix, right, in command main. So now for the source file organization, so declaring grouping. So declaration grouping, these principles actually encourage you to source file organization. It's declaration grouping principle encourages you to group related declarations like classes, top level functions, and properties within the same Kotlin source file. Okay, so this practice improves code readability and maintainability to keep related concepts together. So if you go out and check example, let me see. Yeah, this is a example here in the user example. So imagine that you have a user, a class, and functions for the user authentication, like you have a authenticate user and logout user, right? So instead of creating separate files for the user, authenticate user and logout user, they are grouped in a single file, users.kotlin. So they are grouped in the single file because they are semantically related, all dealing with the user management, right? So this is how you should do it. Okay, so if they are semantically related, all dealing with the with user management, they are all been declared, been defined here. Okay, as you can see here. So note that keep the file size reasonable, under a few hundred lines. If a file becomes too large, consider splitting it into smaller, more focused files. Okay, so now let's talk about the extension function. So extension functions are a powerful feature in Kotlin, allowing you to add functionality to existing classes without modifying their source code. So there are some general purpose extensions like string extensions, like you can check out this example. So this is a general purpose extension. Okay, so if the extension function is really relevant to all clients, for example users of a class, place it in the same file as the class itself. Okay, so so string extension is placed in the same class itself. So this makes it easy to discover and use the extension alongside the class it extends. Okay, so if it is general purpose, this is the example. But if it is a client specific extension, so for that, let me give the example. Let me see if I have an example. Yeah, this I have an example. So if it is a client specific extension, so this is the example of a client specific extension. So if the extension function is only used by a specific client, like a particular class or module, we need to place it next to the client's code. So so this avoids cluttering the original class with extensions that are not widely used. Okay, so this is the example of a client specific extension. So we need to avoid extensions only files. So don't create files solely for the holding extension functions. So this practice can lead to scattered and less discoverable extensions. Instead, group extensions into within the class that extends classes they extend, or the client they use them. Okay, and now for the class layout, organize the contents of a class in the following order. So if you go and check out my example, in my previous example, like my Kotlin tutorial class, you need to organize the content of class in the following order, as you can see here. So you need to have a property declaration and initializer block. so property declaration and initialized block. Okay, so then here you have a secondary constructors. These are the secondary constructors. Then you have a method declarations, and then you have a finally the companion objects. So this is the standard way of organizing the content of a class in the following order. Okay, so this is very important, guys. Okay, so now what about the nested classes? Place nested classes next to the code. They use them if intended for external use. Place them at the end, so after the companion object. So uh, let's talk about the interface implementation layout. So if you check out my example, so when implementing an interface, maintain the same order for implementing members as in the interface definition. Group overloading functions together within the classes. So as you can see here in the example, we need to group overload functions together within the classes, because as you can see here is the same name, but it has a different overloaded parameters, right? So it has only one parameter, so it's called radius. It has two parameters called width and height. So you need to group overloaded functions together within the classes. So okay, finally, by following the guidelines that I showed you, you will create a well structured and maintainable Kotlin code base. So this will enhance readability, collaboration within your team members, and a long-term project health. And thank you, guys. If you like my content, please do subscribe me, and catch you up in the next lecture.